So before anything else, let me introduce to the topical workbook for computer science 2210 or 0478. This is the workbook 1 for paper 1, basically computer systems. And as you can see from the table of contents, I've included questions on each and every subtopic from the syllabus along with the mark scheme. And these are some of the actual questions, actual pages as a preview from the workbook. Section 1.1, 1.3, 2.2, 3.2, 5.3 cybersecurity and artificial intelligence. This is just to show you a glimpse of what type of questions are included in the workbook. There are many more questions where these come from, and around 18 to 20 questions on an average are included for each and every topic. A must buy if you want to boost your grade. Similar to the paper 1 workbook, I have designed a paper workbook for paper 2 as well. This is for algorithm, programming and logic for CIEs either 2210 or 0478 GCE or IGCSE Computer Science. As you can see, it contains questions on every subsection of the syllabus content for paper 2 along with the mark scheme, so you can understand each and every question, each and every algorithm. These are some of the few pages from the workbook just to give you a glimpse of what type of questions are included. As you can see, this is 7.1, this is 7.7, 8.3 and section 10 Boolean logic. So a lot more questions are included in the workbook. A must buy if you want to have a very good score in your Cambridge examination. Order now. Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another physics lecture. So we were discussing section 3.1, the general properties of waves. Moving ahead, let's see how to demonstrate wave motion. Properties of waves such as frequency, wavelength or wave speed can be observed using an equipment that is known as a ripple tank. This is what a ripple tanks look like. It has a tank full of water and an oscillating pad that is fixed with a motor, and it has basically a shallow tank of water with some illumination on top. When the motor is turned on, it oscillates and produces waves or ripples in the tank, and they can be observed in the screen below. The wavelength of the waves can be determined by using a ruler to measure the length of the screen, this part, and dividing it by the number of the wavefronts, means these lines. The frequency can be determined by timing how long it takes for a given number of waves to pass a particular point, and dividing the number of wavefronts by the time taken. The wave speed can then be determined by the formula: a wave speed equals to frequency into wavelength. Then we have reflection, refraction and diffraction of waves. All waves, whether they are transverse or longitudinal, can be reflected, refracted and diffracted. What is reflection? Reflection occurs when a wave hits a boundary between two media and does not pass through, but instead stays in the original medium. Waves hit a wall or any other media and then they are reflected back. The angle of reflection and the angle of incident are always the same. The angle at which the wave would strike a hard boundary would be the same as the angle at which the wave would be reflected back. The law of reflection states that angle of incidence is equals to angle of reflection. Then we have a refraction. Refraction occurs when a wave passes a boundary between two different transparent media and undergoes a change in direction. Like this, the wave was coming from over here in air, and then when it went into water, it changed its refraction slightly. The angle between the angle of incidence and angle of reflection are different. Angle of incident was bigger, whereas angle of reflection is smaller. When waves enter a different medium, their speed can change and they bend towards the normal. This effect is called refraction, and it can have two possibilities. The wavelength can increase or decrease, and the wave can change direction. If the wave slows down, the waves will bunch together, causing the wavelength to decrease. The waves will also start to turn slightly towards the normal. If the waves speed up, then they will spread out, causing the wavelength to increase. The waves will also turn slightly away from the normal. These are the possibilities of what can happen during a refraction. The last thing is the diffraction. When wave passes through a narrow gap, the waves spread out. This effect is called diffraction. This is the wave, and when it is made to pass through this small slit, it bends. This is known as diffraction. It only happens when the gap is smaller than the wavelength of the given wave. If the gap is bigger, then the wave is not bent so much. As the gap gets bigger, the effect gradually gets less pronounced until, in the case the gap is very much larger, the wave no longer spreads out at all. If the gap is bigger than the wavelength of the wave, then the wave does not bend, does not spread, it simply passes through. Whereas the smaller the slit is, the smaller the hole is, the more spread out the waves are. Diffraction can also occur when wave passes over an edge or an obstacle in the ripple tank, and this causes the wave to be slightly spread out towards the edge where there was an obstacle. Ripple tanks are commonly used in now this part of ripple tank basically discusses ripple tank with the point of view of paper 4 questions. Now what you know already, ripple tanks are used to demonstrate reflection, refraction and diffraction due to a gap or due to an edge. How you can investigate reflection? This can be shown by waves hitting a plane such as a wall or a mirror inside a ripple tank, whereas for investigating refraction, it can be shown by placing a glass block in the tank. The glass block should sit below the surface of the water and cover only some of the tank floor. The depth of the water would become shallower where the glass block is placed, and since speed depends on depth, the ripple slows down when traveling over the block. And this model of refraction shows how a wave slows down when passing from deep water into shallow water. This would be a good model. You would simply place a glass block on the floor of the ripple tank to demonstrate it, and the results would be given on the screen. For investigating diffraction, it can be shown by placing small barriers and obstacles in the tank. As the water waves encounters two obstacles with a gap between them, the waves can be seen to spread out. As the water wave encounters the edge of an obstacle, the waves can be seen to spread out on screen. The amount of diffraction depends on the size of the gap compared to the wavelength of water wave. The higher the frequency of the motor, the shorter the wavelength. The lower the frequency of the motor, the longer would be the wavelength. This is how you determine the frequency of waves in a ripple tank, by using the speed of the motor if it is given in the question. Example question. A water wave is produced in a ripple tank. The water wave in the ripple tank transfers energy. Describe how to show that there is a transfer of energy and not matter. Basically, how you can demonstrate is that you would simply observe the surface of the water, or you would place a particle or a cork on the surface of the water, and the observation you would make would be that the particle or the cork would move up and down at its position and it will not move ahead. State what is meant by a wavefront. The line or an imaginary line joining points that are at the same position in the motion. Figure shows the variation with time of the height of water at the same place in the tank for two waves P and Q. The height is sometimes above and sometimes below the mean level, which is marked at 0. This part and this part. State one difference and one similarity of the two waves. The difference in Q, it has a greater amplitude. As you can see, this height is greater than this height. The second one, the similarity, they both have the same frequency. Both of these waves, both of these diagrams have two waves. 1, 2.5. 1, 2.5. Both of these diagrams have same frequency but different amplitude. They have same time or same period for one wave. They are both transverse waves because the diagram shows that, and they both oscillate up and down and not sidewise. The speed of the water wave is 0.2 meters per second. Determine the frequency. For frequency, we use the formula F equals to 1 upon T, or 1 upon period. Time is 300 seconds or 0.3 from the graph. We find it. How we find that? This is the time period for, this is the time for one wave. That is 300 milliseconds. 300 milliseconds would mean 0.3 seconds. So we simply divide it by 1. 1 divide, this would give us 3.3 hertz. The wavelength of wave P. How do you find the wavelength? Simply we use the formula lambda is equals to speed divided by frequency. We have just found out the frequency. We put in the formula, the speed is given over here, 0.2 divided by 3.3 would give us 0.06 meters. That would be the wavelength. That's it. That's everything you need to know about section 3.1. If you have any questions, feel free to ask me. I'll make sure to answer. I hope you have understood everything. I'll see you guys in the next lecture. Take care. Allah Hafiz.